guys, so the last section of this chapter is parallel and perpendicular lines. So we are going to start with a couple of definitions. So lines in a coordinate plane either intersect or are parallel lines, okay? So these are the two words that you're plugging in, intersect or are parallel. So parallel lines are lines that are in the same plane, meaning they're graphed on the same coordinate plane, that never ever will intersect, even if they keep on going forever. So these are two examples of the graphs that are graphed. Y equals 3x plus 1 is this blue graph, and y equals 3x minus 2 is this green graph. So you might notice that they both have this 3 multiplied by the x. Well, that's your slope. So a property of parallel lines is that they always have the same slope. If they don't, they're not parallel lines, okay? So they have the same slope, but they have different y-intercepts. So they cross the y-axis at different points, okay? So as you can see, the blue one crosses at 0.1, and the green one crosses at -2. So the first problem that we're going to do together is one that says a line passes through the point 12,5 and is parallel to the graph of y equals 2/3 x minus 1. What equation represents the line in slope-intercept form? So it told us that our line is parallel to this line right here, and it goes through this point 12,5. So first, let's look at this line that it's telling us our new line is parallel to. We know that parallel lines have the same slope. So I'm going to pull out the slope from this equation, which is 2/3, which is going to be the slope of my new line. So we are given a point and we have slope. So we're going to put this into our point slope formula. And then we're going to solve for y, okay? So we get y minus y1, which is 5, equals 2/3 times x minus x1, which is 12. So we want to distribute the 2/3, so we get y minus 5 equals 2/3 x minus, and if you multiply 12 to 2/3, you get 8. So we want to move this 5 over to the right-hand side, and we end up with y equals 2/3 x minus 3. And this is the equation of the line that's parallel to the line given that goes through the point 12,5. So you guys are going to try the next one on your own. You're going to do the same exact thing. It says that it's parallel to this line y equals 2x plus 3, so you're going to use that slope of 2 and plug in this point -3, -1 to figure out what your equation is. So next up, we're going to review perpendicular lines. So perpendicular lines are not just lines that intersect. They intersect to form right angles, meaning that they form a right angle where these lines intersect on all 4 corners, okay? So some properties of perpendicular lines, if you take a look at the slopes, we have 1/2 and we have -2. The slopes of perpendicular lines are opposite, meaning if one is negative, the other is positive, and then reciprocals, so the flipped fractions, okay? Another property of the slopes is that the slopes, when you multiply them together, so we're going to test this out, 1/2 times -2, and this is the same thing as -2/1. When you multiply, you always get -1. So if you multiply opposite reciprocals to each other, you get -1. So there are some examples of opposite reciprocals. So we could have 3 and -1/3. We might have 2/5 and -5/2. So as you can see, you flip the fraction and you make it negative, or you change the sign. So next up, example 2, we only have 2 more to go. It wants us to tell whether the graphs of 4y equals -5x plus 12 and y equals 4/5 x minus 8 are parallel, perpendicular, or neither. And it wants us to explain. So in order to figure this out, we need to look at our slopes. So if they're the same slope, they're parallel. If they're opposite reciprocals, meaning if they multiply together to get -1, they're perpendicular, or they just have nothing to do with each other and they're neither. Okay, so in order to figure this out, we want to solve this first equation for y so we can identify what our slope is. So we get 4y equals -5x plus 12. And in order to get y alone, we need to divide by 4 everywhere. So we get y equals -5 over 4x plus 12 divided by 4, which is 3. So in this case, my slope is -5 over 4. And my slope over here is 4 over 5. So my slope here is 4/5. So they're obviously not the same, right? One's 5 over 4, one's -5 over 4, one's 4 over 5. So they're not parallel, so that can't happen. So what we want to do is try to multiply them together and see what we get to see if they're perpendicular or neither. So we're going to multiply -5 over 4 times 4 over 5 and see if we get -1. So -5 times 4 is -20. Divided by 4 times 5, which is 20. So we end up with -1, which means that our lines are perpendicular. And the reason is because the slopes are opposite reciprocals of each other. I just don't have enough room to write that. So again, you guys are going to do the same thing for the problem right under this. Solve for y, get y alone, and see if your lines are parallel, perpendicular, or neither by looking at your slope. All right, and the last one says that it wants us to write an equation that represents the line that passes through 2, 4 and is perpendicular to the graph of y equals 1/3 x minus 1. So the slope of this graph is 1/3, and I want the opposite reciprocal. So I need to flip my fraction and make it negative. So it becomes -3 over 1. Which is just -3. So I'm going to use this as my new m. So we get y minus y1, which is 4, equals -3 times x minus 2. This x and this y come from the coordinate point that was given. And now I can distribute and simplify to get y alone. So we get y minus 4 equals -3x plus 6, add my 4, and we get that y equals -3x plus 10. And this is my equation in slope-intercept form. So last one is for you guys to do on your own. It wants the line that passes through 1/8 and is perpendicular to the graph of y equals 2x plus 1. And it wants the answer in slope-intercept form, meaning you need to get y alone. And that's about it. Have a good night.